Welcome to this video. My name is Mark Scythian. The date today is January 22nd, 2025. So this video is propeller static thrust revisited. So here's another more practical method to calculate propeller static thrust. So assume we have a 0360 horizontally opposed reciprocating piston engine on a Cessna 150 driving a 76 by 28 propeller, and we want to mathematically calculate the static thrust of this two blade propeller. So it is a constant speed propeller, but it is, let's say, in the climb propeller pitch setting at 28 inches propeller pitch. So we can start by solving for the propeller cross-sectional area. So we take the 76 inches, convert it to feet, divide it into 2 to get radius squared times pi, so we get 31.6 square feet of propeller cross-sectional area while rotating at 2700 RPM. So then we take the 28-inch pitch, so that's the inches airflow displacement per revolution, and convert that to feet. So 2.13 feet per revolution of propeller airflow displacement per revolution. Then we can multiply that times the revolutions per second, 2700 RPM divided by 60. So when we do so, we get a propeller discharge airflow velocity at 2700 RPM of 95.85 feet per second. So the average air density is 0.0023 slugs per cubic foot times 32.2 pounds per slug. So we get 0.074 pounds per cubic foot average air density. Now, by taking the cross-sectional area times the propeller discharge speed, we introduce a third dimension from cross-sectional area to volume. So 3,029 cubic feet per second of airflow volume discharging behind the propeller, and then times the average air density. So we calculate 224.15 pounds per second of mass airflow. We have an 80% propeller efficiency average industry standard. So the propeller static thrust at 28 inches pitch and 2700 RPM is then calculated at 667.2 pounds static thrust, but that's at 100% propeller efficiency. So if we take that value and we multiply it times 0.8, we can calculate the propeller static thrust to a 95% accuracy. Of 534 pounds static thrust. So this is relevant to two blade propellers only, and if you have more than two blades, there is a logarithmic conversion that is taken from two blades to more than two blades, or multi-blade, 3 or more. So one other question I've received in comments regards the coefficient of thrust, like the coefficient of lift if this was a wing, but we have a twist from root to tip to equalize the thrust distribution, since the airflow over the propeller blade is a function of the circumference. So that C sub L, coefficient of lift, becomes the C sub T, coefficient of thrust. So we can still use the aerodynamic lift equation, and we can just solve for the CL algebraically. Since the propeller blade is rotating literally at all degrees simultaneously at the 2700 RPM, which is 45 revolutions per second, we use the entire cross-sectional area for the A value, 31.5 square feet. So we calculate a propeller coefficient of thrust equal to 1.6. So the typical range for like a Cessna 150 coefficient of thrust, propeller coefficient of thrust, is between 0.3 to 1.6. So obviously this pitch setting is in the climb setting for maximum thrust at minimum true airspeed. So that is another consideration in the final calculation. Thank you for watching this video and have a great day.